You can tell, so its luminosity is the absolute brightness, but you can also tell the apparent brightness of a star by looking at where it falls temperature-wise. You can tell the luminosity, both apparent and absolute. Well, how so? It's something called the spectroscopic parallax. Okay, so remember the parallax was you can look 6 months apart and kind of see the distance and then do some Pythagorean theorem and get the actual distance, right? So this is spectroscopic parallax. So you can take the apparent brightness and the spectral type, right? That's the color coding. And you can get the luminosity, which is the absolute brightness, right? 10 parsecs away, 33 light years, blah, blah, blah. And then you can use those three things to calculate your distance to the star. Yeah, there's some math and formulas and whatnot that goes into that. But if you have those things, you can calculate the distance to the star. Well, why don't we just look and see, right? Doesn't quite work that well. So from Earth, if you're 1 AU away, if you were a star and you're 1 AU away from us, we can get your radar and find out what's going on with that star. From 1 AU to 200 parsecs, you're looking at the stellar parallax, right? From 6 months away or 6 months apart, and you can see the distance, Pythagorean theorem, blah, blah, blah. Now, if you're going further than 200 parsecs, remember that we think the next jump's going to take us to 25,000 parsecs. So 200 to 10,000 parsecs, you have to use this spectroscopic parallax. So you have to use the HR diagram and then those calculations. Now, I'm not sure what they're going to do for 10,000 to 25,000 because that's what we think our next jump is going to be.